All right, I'm going to move on to example 3. I bet some of you are really not happy that I'm doing the videos now because they're probably going to be much longer. But take heart, because for my linear algebra students, I embed like 10 to 15 check for understanding questions that they have to do and get graded on, and I made it so they can't skip ahead on the videos. So it could be worse. Okay, the dimensions of a car tire are shown to the nearest foot, so make sure that's something I typically miss, that you're rounding to the nearest foot. How far does the tire travel when it makes 15 revolutions? A revolution is basically a circle or the circumference. So 1 revolution is the circumference is pi times diameter. So first I'm going to find 1 revolution. So pi will be pi. The diameter, okay, the diameter is basically all of this. So we'll add all that, 15 plus 11, basically 5.5 and 5.5 is 11. So that's 26. Then you might as well, while you have your calculator out, you might as well multiply that by 15, because this black part, 26 pi, is 1 revolution, and we want 15 revolutions. So you just plug that whole thing into your calculator, and I'm getting 1,225.22 inches. The other thing that's really easy to miss is that it says to the nearest foot. This is all in inches, So if I'm going inches to feet, I'm going to divide by 12. And I'm going to round to the nearest foot. That would be 102 feet. So that's example 3. All right, let's do example 4, and then example 5 and the summary might have to be a second video so that I can upload it to YouTube. All right, so here's example 4. If it was me and I was making my notes, I would just draw the diagram and not necessarily do all those words, but it's up to you. So the curves at the end of the track shown are 180-degree arcs. So that's kind of saying that these are semicircles right here. The radius of the arc for a runner on the red path is 36.8. So that's kind of shown to you right here. And I didn't draw this picture. I didn't draw that line very well. Let me redraw it. So here it's supposed to go through the center. That is my semicircle. And here's the radius, 36.8. Same thing over here, but the radius is 44.02 meters. So let me erase this so you can see the diagram. And I'm going to draw this maybe like a dashed line. There we go. So we have 2 semicircles. About how far does this runner travel to go once around the track, round to the nearest tenth of a meter? Tenth is 1 decimal place. All right, so basically for our track, the runner, we'll maybe try yellow. Let's say the runner starts here. They do a semicircle, okay, in yellow right there. They do this straightaway. They do another semicircle. We'll make that red. Oh, red's kind of hard to see because it's already red. We'll make it blue. They do another straightaway. So there's basically 1, 2, 3, 4 parts. So the straightaways, the black parts, are pretty straightforward. Those are both 84.39 meters. So I'm going to add 2 of those. That's going to be the straight parts, which is 168.78 meters. Then we need to find the curves. So for the curves, we need to be doing, the curves are circumference, pi times diameter. Then for my diameter, my radius, all right, it tells me that my radius of the arc is 36.8. So the diameter would be double that, 73.6. How did I get 73.6? I did 36.8, the radius, times 2. That's where that came from. So the circumference is giving me 231.22. And then you might be wondering, but shouldn't you be doing half because it's only a semicircle? but you have two of them, and if you put them together, it's a whole circle, it's a whole circumference. So your last step is to take 231.22 and add 161.78. If I round to the nearest tenth, I get 400 meters, and I'm not a track star, but I do think a lot of tracks are a 400-meter track, and that's a common distance. All right, I am going to just try, since we're almost with the notes, to kind of plug along, and it might just take a little longer for this video to upload, but hopefully that will work. Okay, so core concept, degrees to radians. It's basically two different forms of measurement, kind of like we have Fahrenheit for temperature in Celsius, or we have centimeters and inches. So they're just two different measurement systems. And you'll learn more in Algebra 2 and pre-calculus more about radians, the unit circle, and radians do come in handy sometimes and are really slick, kind of like radicals. You can do some cool things with them. For our purposes, we are mostly using degrees this year, but we are going to be kind of introducing the concept of a radian and how to convert between them. So these formulas, please make sure you pause the video, that you write them down. Again, you can use your notes on any of the quizzes and tests, so you want to make sure you highlight. That's why I asked you to highlight these so you can find them. All right, and then I will go through part A and part B, and for some reason this is either really easy or really hard for students, so we can work on this more if needed. Part A, convert 45 degrees to radians. So I'm going degrees to radians. So that is my first formula up here. So I'm going to take 45 degrees. I'm going to multiply it by my conversion factor. So I tend to use this one. I just think it's a little simpler, the pi over 180. So I'm going to multiply by pi radians. I'm going to abbreviate radians to RAD over 180 degrees. So where did I get this part from? Right here. That was my conversion factor. So when I multiply that, I get 45 pi radians that's just everything. 45 pi radians. I multiply, I get it all. On the bottom, I have 180 degrees. So first of all, let's cancel out our degrees. Degrees. And then basically what you need to do, and what's kind of hard for some students, so the degrees canceled, is you need to reduce your fraction. So you have 45 over 180. You need to reduce that. So I'm going to divide by 45. And sometimes you have to guess and check. If you started with 5, that would be fine. You would just have a little more reducing to do. So I get 1/4. So generally, instead of writing 1/4, we just write that as pi over 4. And the 1 is kind of invisible, if you will. So like the 1/4 would be written like that as a fraction, but since 1 times anything is itself, I'm going to erase that. So it's pi over 4 radians. So the degrees canceled out because I had a degree on the top of my fraction and a degree on the bottom. So those canceled. What did I have to do? I had to take my numbers, my fraction 45 over 180, and I had to simplify or reduce that. And then my units are radians. So pi over 4 radians. So you cannot be putting these as decimals, 0.25. They need to be in fraction form. All right, part B. Convert 3 pi over 2 radians to degrees. So now I'm going radians to degrees. So, and I think this direction is generally a little bit easier for people. So 3 pi over 2 radians. I'm going to multiply times my conversion. I like to use this one. So I'm going to multiply by 180 degrees over pi radians. So again, your radians, since you have a radians on the top and a radians on the bottom, those cancel, which is the point because you're converting from radians to degrees. And you just need to kind of take your numbers. So 3 times 180, that gives you 540 degrees. Okay, your pi's are also canceling. Pi on the bottom, pi over 2. You divide that and you get 270 degrees. So we did 3 times 180, we got 540. We divided that by 2, we got 270 degrees. The pi's canceled, the degrees canceled. I mean the radians canceled, excuse me. Okay. Baby Jen was a little sick too, so she's having a hard time, so I'm sorry if I hurt a little bit. Okay, so the homework problems, those will be up on Big Ideas. The summary questions, there's some typos, but these are actually PDFs, so it's just really hard for me to change them. So I apologize. You'll just have to deal with that. Summary, what is the definition of circumference? So what actually does it mean? So something kind of like perimeter. What are the formulas for circumference? What is pi? Not 3.14, but what is it? What is the ratio? What is the definition and formula for arc length, the S? And then how do you convert? What's the process of going from degrees to radians and radians to degrees?